Hello and welcome. Good evening. This is Sudhanshu Pandey from Maths and Fun. Today I'm with Anjana and we are going to learn matrices of grade 10 and that is for ICSE board. So first of all, we would like to understand what are the matrix vocabulary. I think this is being already done with you, Anjana, in the demo class. So we will go fast with this. So matrices, capital letters are used. How we can define any matrices? If I want to write it, I will use the capital letters. This is the basic things. You can't write a matrix name with a small letter. Each number in the matrix is called an element. Suppose I write Z is equal to, let us say, -1, 2, 3, 4. So what are these numbers? They are known as elements. A matrix is characterized by its dimensions, the number of rows and the column it has. So if I want to characterize this matrix, I will say it has got 2 rows. Can you see that? And these are the 2 columns, we can say. So it is known as 2 by 2 matrix. It will be known as 2 by 2 matrix. Okay. An M by N matrix has M rows and N columns. Alright. Good. Now you can see these are the columns. 1, 2, 3, 4. These are the rows. Each number in a matrix is called an element. So what are these numbers known as? These are known as elements. Alright. And M by N matrix, this is already done. And elements A, I, J. So I, J, why we are using I, J? Because in a general term we are saying I and J can be any number ranging from the number of rows to the number of columns. So what is the value of I in this case? So I can range from 1 to 3. It can be 1, it can take 2, it can be 3, it can be 4. Because the total number of rows is 3 only. And the total number of column in this case is 4. So J will range. What is the range of J? J will range from 1 to 4. Alright. If somebody will ask you what is A13, that means they are asking what is the first row, third column. What is the element of first row in the third column, and here it is 8. Good one. Now let us understand the types of matrices. So a square matrix is the same. So first of all, let us say the row matrix. You can see the row matrix has got only one row, single row. The column matrix has got only one column. Zero matrix, all the elements of a matrix is 0. We say it is a zero matrix. And identity matrix. So if all the diagonal elements of a matrix are 1, we say it is a identity matrix. Okay, identity matrix is a square matrix, and it is a square matrix for sure, because you can't make a matrix like this. Let us suppose you say 1 0 0 1 and then you can write 0 1 again. So this is not a square matrix, and you can't find a diagonal in this as well. So that means this is not a identity matrix. So identity matrix is a square matrix that has ones and the diagonal, and zeros are everywhere else. And these kind of questions are required to understand the basic fundamental, because this can come in the type of question, you can say assertion and reasoning. So you have got 4 options. So they will say an identity matrix is a matrix that has ones in the diagonals and zeros everywhere else. So that statement is false until unless they say it is a square matrix. So a square has a very important role in this. Okay, I can manage to disappear any one word from this definition and just prove it wrong. Are you getting it?
Yes.
So you have to be very careful. A zero matrix is a matrix where all the entries are 0. These are the special matrices. And a column matrix has exactly one column, a row matrix has exactly one row, a square matrix has the same number of rows and column. Now adding and subtracting matrices. Okay, so adding and subtracting, how we represent matrices, we represent like this. We have already discussed this. So if we are adding 2 matrices, first of all, when a matrix can be added? So we can only add if they are of like dimensions, means the number of rows has to be same and the number of column will also has to be same. If they are not same, then in that case it is undefined. You can't add them. You can't add apple to oranges to make, okay, I will add 2 apple and 3 oranges to make a fruit juice. No, that won't work. in mathematics at least. You can add only the like terms. Okay, so you can add only the like matrices. Like matrices means number of rows and column has to be same, and if you are adding it, you will add the corresponding element. You will see that here this element will be A plus E, that will be B plus F, C plus G, D plus H. Understood? Easy?
Yeah.
Okay. Now multiplication of a matrix is by a scalar. Now what is a scalar? In physics also you might have learned it. Scalar is a number. Scalar is any number. Okay, so for example, if I ask you, there are two different types of quantities. One is scalar and one is vector. Distance is a scalar quantity or a scalar or it's a vector? Scalar. Okay. What about displacement?
I think I got it wrong.
No, you were right only. So displacement is a vector quantity, distance is a scalar quantity. So a scalar means we just keep adding the numbers.
Okay.
What we do, we just keep adding the numbers. So if I add 2 plus 3, for example, let us say this is 3, this is 4, and we are going from A to O via B. So if I ask you how much distance I have covered, you will just add the scalar 3 plus 4. How much it is? 7. But if I ask you what is the displacement from A to O, so that is the shortest distance that you can follow. So the shortest distance is AO. So AO can be found by finding the under root of 3 square plus 4 square, which is 25. So under root of 25 is how much? 5. So where the direction has an important role, you say it is a displacement, which is a vector quantity. So a scalar is what? Scalar is just a number. You can multiply any matrix by any scalar. Okay? It is a constant, you can say. So for example, find the product of 4 times this matrix. So you will multiply 4 by 9, 36, 4 times minus 2, minus 8, 4 times 6, 24, 4 times 1, how much? 4. Are you getting it?
Yes.
Wonderful. Now multiplying two matrices. So multiplying, there is a rule. What is the rule? Two matrices can be multiplied only if the number of column from the first must be equal to number of rows from the second. Alright?
Yeah.
So how to remember it? For example, suppose in the examination you just forgot. So what you do, you will write the first matrix. You will write, like, let us suppose it is m by n. So you have to focus on the second part. And the second matrix must be n by, let us say, z. So second matrix, the first part should be same, because this must be equal. This must be equal. If they are not equal, it is undefined. You can't multiply them. Okay? And what will be the result? The resultant matrix. If somebody will ask you what will be the order of the resultant matrix, so the first part here and the second part from here. So it will be m by z matrix. So what will be the resultant for this? Tell me. In this case?
In that case, and z. So that will be 3 times 3.
3 by 3 matrix. So if I multiply this, the resultant I am going to get is 3 by 3 matrix. Okay, let us find all the three values. So let us find the first value, how it is being done. So first 1 will be multiplied by 2 and 3 will be multiplied by 8.
Okay.
So how much you will get? 1 into 2 is 2, 3 into 8 is 24. Add them. So you will get 26.
Okay.
Now going to the second part. So second part means the second row now. Now the second row will be multiplied by the first one.
Oh, okay.
Okay. So 5 into 2 is how much?
10.
And 7 into 8 is how much?
56.
56. 56 plus 10 is how much?
66.
Now the third row and the first column.
Okay.
So 9 into 2?
18.
18 plus 0?
0. Sorry, 18.
Okay. So First column done, first row done. Coming to the second row.
So
Now
we do the same to the second column.
what?
We do the same whatever we did for the second column in the same way.
Yeah, I think I made some mistake. Okay, so 1 into 3 must be multiplied by 2 into 8. Then 1 into 3 must be multiplied by 4 into 0. Sorry, I made a mistake. 1 into 3 must be multiplied by 4 into 0 to go to the second part. So 1 into 4 is 4 and 3 into 0 is 0. So the answer will be 4. Okay, and then 1 into 3 must be multiplied by 6 into 2. So 1 into 6 is 6, 3 into 2 is 6. So it will become 12.
Okay.
Now,
the same 5 and 7 and 2 and 8.
yeah, then 5 and 7, 4 and 0, then 5 and 7, 6 and 2. Second row will follow the second row, third row will follow the third row.
Okay.
Alright, everything will be multiplied by the column. The row is multiplied by column. Are you getting it?
Yes.
Good. So rules for multiplying the matrix by the another matrix. So remember to check. The number of columns in the first matrix must be equal to the number of rows in the second matrix. Please note it down. Please write it down because this is the important thing that will be required for you. Rules for multiplying a matrix by another matrix. ना कुछ कर रहे हो? नहीं तो चाचू के साथ चले जाओ.
Yeah.
Okay. So product will have the same number of rows as the first matrix and the same number of columns as the second matrix.
Just a doubt, I've heard something called scalar multiplication. Is that a different concept?
Scalar multiplication is just the multiplying a number by the scalar.
Okay.
Scalar was a number. We earlier did this, I think. This is scalar multiplication.
Okay.
You are multiplying a number by a scalar. So this is scalar multiplication.
Okay.
So product of a matrix by a matrix and product of a matrix by a scalar are two different things. When you are multiplying a scalar by the matrix, you are multiplying all the elements of the matrix by that scalar. But when you are multiplying a matrix by a matrix, then in that case there are certain rules which are to be followed.
Which we did earlier.
Yes.
I feel like I did something different that I'm getting confused between it.
If you have any questions from the book, you can just let me know. I will write it here and we will solve it together.
Yeah, sure.
But first, let's complete the theory part first.
Yeah, definitely.
Okay, so written this as well. So product will have how many rows? The same number of rows in the first matrix and same number of columns in the second matrix. And how you can write it? You can write in the same way, this way. So 3 by 2, 2 by 4. So the resultant will be 3 by 4. If the question says 3 by 1 and 2 by 1, so there may be a question in the assertion and reasoning that may come. This matrix can be multiplied by this matrix. A 3 by 1 matrix can be multiplied by 2 by 1 matrix, the first statement. So the answer will be assertion is false. Assertion is false. And the reason they may give is, they may give like this. So they may trick you. They may write 3 by 1 is multiplied by 3 by 3. And they will say the 3 by 1, the order of 3 by 1 matrix A is of the order 3 by 1 and the matrix B is of the order 3 by 3. They both can be multiplied. The product can be found using the multiplication of matrices for assertion. And reason they will say two matrices can be multiplied if the number of rows in the first matrix is equal to the number of column in the second matrix. So now in that case you will say it can't be multiplied.
Because number of columns should be equal to the number.
Yes, in fact 3 by 1 matrix can't be multiplied by 3 by 1 matrix. That means a matrix can't be multiplied by itself as well. If it is not a square matrix, please see this. If a matrix is not a square matrix, a matrix cannot be multiplied by itself as well. Okay, only if it is a square matrix it can be multiplied, because in that case all the numbers will be same. Either it will be 2 by 2 or it will be 3 by 3. So in both the cases the number of column and the rows will be same. Are you getting it?
Yeah.
Okay. So here also I want you to write this as well. Please, you can please so that it is a benchmark to understand easily.
Okay.
And you also write matrix multiplication is not commutative. A into B is not equal to B into A.
Okay.
Done?
1 minute.
Okay.
Yeah.
Good one. For example, let us say find the product. So let us do this question. So first you will see that 3 into 0, first of all you have to check. This is a square matrix of 2 by 2 order. This is also the square matrix of 2 by 2 order. So the total number of, so matrix multiplication is allowed here. Okay.
Yeah.
And 3 must be multiplied by -2 and 0 will be multiplied by 1. Now the first row and the second column. So 3 will be multiplied by 9. How much you will get? 27. 27. And 0 into 4 is how much? 0. So if 0 is added, it will become 27 only.
Yeah.
Now coming to the second row. So second row will be multiplied by the first column. So how much you will get? Tell me.
-4 plus 1. So -3.
Very good. What about the next one?
18 plus 4, 22.
So easy.
Yeah.
So multiplying the corresponding elements and add up the results. That's it.
Okay.
You can write this as well. Take the example. Write the example and write it. We will do more of the examples from the textbook as well.
Okay.
In the ICSE we do have a lot of questions. And immediately we get the response whether it is right or wrong.
Yeah, it also explains if it's wrong.
Yes. So it's a self-learning. But you need a tutor just to know where is what. It is a huge sea of knowledge.
Okay. I learned this type of multiplication as scalar multiplication.
No, this is not scalar multiplication. This is a matrix multiplication. The product of matrices. Scalar multiplication is, scalar is a number, dear. So you just multiply the number by all the elements. That is the scalar multiplication.
Okay.
Okay?
Yeah.
So it happens sometimes the teacher is saying something, they might have the slip of the tongue, or you might have the something in difference with the hearing. Just give me a minute.
Yeah.
Hello. हाँ भैया. हेलो. हाँ अमृत बताओ.
मैंने बात की थी.
ओके.
मेरा आधार कार्ड जो वो है वो तो बंद हो गया. मैंने हजूर साहब गया था ना, मैं महाराष्ट्र. मैंने वो आधार कार्ड अप्लाई किया था, एड्रेस ऊपर का करवाया था.
अच्छा.
तो वो बोल रहे हैं कि पहले एड्रेस चेंज करवा दो.
ठीक है.
तो वहीं पे होगा जहाँ पर एड्रेस होगा.
ठीक है, कोई बात नहीं, हम थोड़ा वेट कर लेंगे. मैं आपको करता हूँ, 1 घंटे में कॉल करता हूँ. अभी मैं क्लास में हूँ. ओके. Okay. So simplifying matrix expressions. So A plus B, how it can be added? A plus B, can they be added? Tell me. Can they be added if I ask you to add this? You can see the number of rows and the column.
Cannot be added.
They cannot be added. But what about the multiplication? Can they be multiplied?
Yeah, because the number of columns in the first matrix is equal to the number of rows in the second matrix.
Very good. So what will be the order of the final matrix, the product matrix? So the number 3 by 3. Understood?
Yeah.
Good one. So matrix arithmetic rules. So addition and subtraction must be done under the same dimensions. They can be done over the same dimensions. So 3 by 3 can be added with 3 by 3 only.
Yeah.
Okay, now scalar multiplication by any dimension. So scalar multiplication can be done with any dimension. You take a number, you multiply with all the elements.
So scalar multiplication is just one quantity being multiplied with the entire thing.
Yes, one simple number is multiplied by all the elements of the matrix. In fact, that can be negative number as well. Sometimes, suppose I ask you what is A minus B. So you have been given A and B. So minus B is what? Minus B is actually the multiplication by negative 1. You change the sign of all the numbers, right? So multiplying it by minus 1 is also the scalar product only.
Okay.
It is not you can look it as a subtraction, and you can also look it as a multiplication by negative 1 and then addition.
Yeah.
Matrix multiplication of columns and rows. So the number of rows and the number of columns must be equal, and you can get the final result. All right?
No.
Any doubt?
No.
Okay. Now let us take one example. So L is given as this, M is given.
So in multiplying the matrix, if the number of rows in the first matrix is equal to the number of columns in the second one, you can't multiply.
No. No, that has not to be looked at. First of all, you should not look at that. What you have to look at it, the number of column in the first matrix must be equal to the number of column in the second matrix.
Okay, so it would be true and false if it's the vice versa.
Yeah, it can be true and false. True and false it will not ask you. They will ask you just assertion.
True and false. True and false.
Yeah, assertion and reasoning it will come in the question like that. Assertion and reasoning. You watch cricket sometimes?
Yeah, I love it.
Okay. So in the cricket match, you see there is a call known as DRS. Sometimes the batsman feel he is not out. Sometimes the bowler feel that he is out. So anybody can take the DRS.
Yeah.
Okay. So now suppose that this is the stump and the bowler is bowling from here, and let us say that in this pitch, this is the line where we can say that the ball has to land. Suppose the batsman is left-handed batsman and the ball is putting here, the first tip of the ball is here, and the ball is going to thrash the stump as well, and the umpire has given out. The bowler has taken the review. So will it be out or not? Tell me.
Not pitching outside.
Pitching outside. So they will not consider itself if the ball is. They will not see the next part. First, so the first part has to be looked at is whether it is pitching inline or not. All right. So the first part that you should look at is whether the column is equal to the row or not. You should not look at the row itself. Never look at the row of the first matrix. Just look the column of the first matrix and the row of the second. If they are equal, then you can multiply, or else you can't multiply.
Okay. Sure.
Okay. So what should be considered is also important. That will save your time, not to look at other things.
I understand.
Okay. So L is this, M is this, and A is 2. You need to find L plus AM. So first you can find AM. You will multiply 2 by all the elements of M.
Yeah.
Why don't you do this? You write L in your notebook, M in your notebook, and then A in your notebook as 2, and then find L plus AM. That's it.
Just Should I solve it?
Yeah, you must. Do you have sibling as well?
Yeah, I have a younger sister.
She is in which class?
4th standard.
Okay.
Yeah.
Done? Okay. Is the answer same?
2, -1, 4, 19, 10, 4, 1, 3, -2. Yeah.
-4?
Yeah.
Good one, beta. Okay, addition and subtraction has already been discussed. You just need to add the corresponding element. That's it. Now the product. So can you find the product once? Write 0, 3, 7, 6, 5. Just multiply them. Check it yourself. Are you getting the same thing? And the number of columns in the first matrix must match the number of rows in the second matrix. The product will have the same number of rows as the first matrix and the same number of columns. So you can write these 2 points as well. If you have understood, no need of that. If you think that you want to make a note of it, you can write these 2 points. But at least do this question.
Yeah. Yeah.
Done?
Yes.
Okay. So have you got the same result?
Yes.
Good one. Scalar multiplication. So now this is scalar multiplication.
Okay.
Okay, easy. 5 multiplied by all the numbers, you will get the result.
Okay.
Now here also, okay, so this is easy. So scalar multiplication, you write this rule as well. Scalar multiplication of a matrices is always defined. The product always has the same dimensions as the original matrix. So these kind of questions may come in the assertion or reasoning.
Okay.
They may give you a different statement which may not be correct as this, or the reason might be something different. And what is the next topic you want me to discuss? Okay.
Heights and distances in trigonometry.
Okay. So
Yeah,
are
I
you?
missed most of the classes, so I barely understood the topic.
What about trigonometry? The basic fundamentals are you clear with?
Yeah, I've been learning from 9th standard, so I'm quite confident with it.
Okay, because height and distance involves. So I don't know how much you have learned actually. So the range of understanding is a great. It may have a huge gap. So if that will happen, then I will make you come to the basics. All right.
Oh, yeah, sure. You can test me on it.
Yeah, that's what I do. I always trust my students, because if they say, sir, I know this, and I also believe that they know this, then it won't work that way, because sometimes you may think that you know something, but from my perspective, I might be asking you something and you are telling me something, so that won't sync. All right. So properties of matrix. Let us see what are the properties of matrix. So can you tell me whether this law is known as what kind of law? If I check PQ is equal to QP, how I can associate with this mathematics?
Commutative. No?
Very good, commutative. But commutative involves two kind of practices. One is addition, commutative in addition, and commutative in multiplication. So addition of matrices is commutative. You add two matrices, if they are happen to be added, then A plus B is equal to B plus A, that is for sure.
Yeah.
But for the case of multiplication, what do you think? Is it commutative?
Yeah.
Is it commutative? Sure.
Yes.
Sometimes dear, it may happen that the commutative part won't be happen as well.
Okay.
Suppose I say 3 by 1 multiplied by 1 by 2 matrix.
Okay.
If I bring this first, now tell me, is this allowed?
Yeah.
But if I bring this first, I ask you whether 1 by 2 can be multiplied by 3 by 1.
Oh, okay. That is not different.
So it might happen that you will land up to that the commutative part is not happening as well. It will not happen.
Commutative if it's a square matrix.
That also is not commutative. We will check as well.
Okay.
It is never commutative. It is never commutative. See, if you just change the row and column, how it can be commutative? The elements are not same. You have changed everything. Initially, you are. Let us check it out. Why don't we check it out? So let us say this is a P and this is a Q matrix, and let us find PQ now. Okay. So I want you to write with me, along with me. So let me take this to the next page. Okay, let us do here. So PQ. So first I will write P, that is minus 4, minus 9, minus 8, minus 9 is multiplied by Q. Q is minus 5, 9, 1, minus 9. So even if it is a square matrix, then what is happening is we can say the commutative is allowed, means the product can be done, but if they are equal or not, let us check it out. So can you tell me what will be the resultant order of the resultant matrix?
2 by 2.
Very good. Now let us multiply the first row with the first column. So, okay, tell me what will come when minus
4 into 5,
20,
back to 4 into 25 and 20, plus first order negative 9 into 1.
so 9, negative 9. So 20 minus 9 is how much?
11.
11. Okay. Now the first row and second column.
Okay, negative 4 into 9, negative 36 plus negative 9 into negative 9 plus 81.
Okay, so negative 36 plus 81 is 45. So 45.
Okay.
Now the second row and first column. Oh my god. Second row and first column. So minus 8 into minus 5 is 40, and 40 minus 9 will be how much?
31.
Very good. Now again the second part. So minus 8 into 9 is how much?
Negative 72.
And 81. So 9.
9.
Are you getting it?
Yes.
Let us check. So is this the same 11, 45, 31, 9?
Yeah.
Right? Okay. Let us try to find what is QP.
Okay.
So QP means Q will be written first. So minus.
It won't be commutative, I understand now.
Now you understood?
Yes. It would be opposite of what we multiplied earlier.
Yeah, let us check it out. Why not to check it out? So
Yeah.
minus 4 into minus 5 is how much?
20.
20. And then 9 into 8 is minus 8 is?
Yeah. Negative 81.
Negative 72. It is 8. 9 into 8.
8, okay. Yeah, okay. Negative 72.
So negative 72 plus 20 is how much? Negative 52.
Yeah.
Now you just check it out here. The first element is not itself the same. So how can it be equal? Two matrices are equal only if their corresponding elements are equal. Even if the first element is not equal, how can you say no need to check about the rest as well? But we can find out. Okay, let's find out. I want you to find all the 3 elements as well. So do it.
Okay.
And let me know. नोट्स बना लिए? अंदर एक बार देखो जाके. So minus 5 into minus 9 is minus 45, and minus 81 plus 45 and plus 81. 81 45 means 36.
Negative 36. 68 and 22.
Negative 4 and plus 72.
68, yeah.
No, yeah, 68, correct.
The other one is 72.
Yes. So does any of the element made any similarity?
No.
So they are not
Commuted.
understood now?
Yes.
Okay. Now is it distributive? Let us check it out whether it is distributive. So yeah, it is distributive. Okay, it is distributive. You don't need to check as well. So we will check in the questions. Further questions we will check it. So this is J, this is K, this is L. Okay, so let's find JK first. So JK they have already found. You can just check it out. Minus 4 into 4 is minus. This is minus 20 and 0 minus 1, so minus 21. All right. Now see this. The second part will be the second row and the first column. So minus 3 into 4 is wait. So minus 5 1 multiplied by this, and then this will be multiplied by this. So minus 5 into 0 is 0, and 1 into 1 is 1. So this is 1. Now the second row will be multiplied by the first column. So minus 3 into 4 is minus 12, and minus 3, so minus 15.
Okay. And then same by the second
0, and then you will get 3. So JK you already have now.
Yeah.
Now let us find JK and JL. So let us find JL as well. Okay, so what is JL? Tell me. Help me with JL now.
JL minus 5 into 1. So minus 5 plus minus 3. Minus 8.
Minus 3. How you got minus 3? Minus 5 into
6. Yeah.
minus 5 into 1 is minus 5, and 1 into 2 is 2.
Okay, one I took the column. Okay.
Okay, okay. No need to panic. Write in your notebook and keep telling me. Keep telling me. I will be writing here as well.
Okay.
So write J first. Write J matrix. Then write the L matrix together. You keep telling me what came in the first column, first row, second column, first row.
Okay. First row into first column. So
Okay.
minus 5 into 1 plus 1 into 2. So 7. Sorry, 3.
Negative 3.
Negative 3.
Good.
And then again by the second column. So negative 10 plus negative 3. Negative 13.
Very good.
And then negative 3 into 1. Negative 3 plus 6. So 3.
Very good.
And then negative 6 plus, negative 6 minus 9. So that is 50, negative 50.
Very good. Now let us add them. So negative 21, negative 3 is how much?
Negative 24.
1 minus 13 is how much?
Negative 12.
minus 15 plus 3 is how much?
Minus 12.
And 3 minus 15 is how much?
Minus 12.
So this is JK plus JL. Alright?
Yeah.
Okay. Now let us add K plus L first. So why don't you add K plus L first? Tell me what is K plus L?
K is 4, 0, minus 1, and 5 minus 1, 2, 4 plus 0, and then 8 plus 0. So first 4, then 8, 0, 4 and then 8.
No, how you are getting it? You need to add K plus L, dear.
K plus L, okay. 5, 2, 1, negative 2. 5, 2, 1 and negative 2.
This one?
Yeah.
Okay. Now, if I ask you, I'm just erasing this because this is not yet required. You have already done it. Now, can you tell me what is J? J is negative 5, 1, negative 3 and 3.
3.
So, we are multiplying now J times K plus L.
Okay.
J times K plus L. Now,
Okay.
I am writing here. Okay. So, can you tell me what is the first row, first column? What will be happening?
First row, first column, so minus 5. Minus 5 into minute. Negative 25 plus 1, so negative 24.
Wonderful. Can you see the first element has same as before? JK
Yes.
plus JL. Okay. Now, let's come to the second part.
Yeah, negative 10 plus negative 2, so negative 12.
Same as there.
Yeah, and then negative 3 into 5, negative 15 plus 3, negative 12.
Okay.
And then negative 6 plus negative 6, so negative 12.
So you can find that JK plus JL is as good as J times K plus L. So this is distributive property.
Okay.
And it is valid for matrices. And it is not only valid for matrices from the left side distributive. So there are two kinds of distributive property. Have you ever, you might have not known this. How many kind of distributive property are there? Two kinds.
Yeah, 2.
Two kinds. Let me show you. The first kind of distributive property is, suppose I ask you a very basic question, let me see, and I will warn you that 99.9% students fail in this question. Okay, so I want you to be among the 0.1% student. Okay,
Okay.
so very simple question but a different part. So 5 divided by 25 divided by 5. Can you tell me what will be the answer?
5 divided by 25 divided by 5.
Yeah, very simple question.
I would say 1.
1. Very good. So you are falling into that 99.9% of the students. Okay. So how to do it? You have to follow the rule, that is left to right. So what brings us easy on us is, you did this first, you got 5 and then you did 5 by 5, which is 1, which is not the case. What should be happening is 5 multiplied by, the basic says that you have to just reciprocate the number, change the division sign, and the same has to be followed the next as well. So you will write 1 by 5 again.
Okay.
And this 5 and 5 will get cancelled out and you will get the answer as 1 by 25. Even if you can ask, you can play the trick with your mom as well. You can ask your parent as well, they will fall into the trap as well.
Yeah.
Okay, so this is not as easy as it looks. So there are two kind of, you can say, distributive property. One is left, one is right. Let me show you. So if I ask you 2 times 10 plus 2, what is it? You will say it is 2 into 10 plus 2 into 2, right?
Yeah.
This is the distributive property. Now let us put it this way. 10 plus 2 times 5 is how much? So you will say, sir, it is going to be 10 into 5 plus 2 into 5. So we say that multiplication is left distributive and right distributive as well. The number is
Okay.
coming from both the ends. Either it is coming from left or right, you can do anything.
Okay.
But is it the same with the division as well? Let us find out. So if I ask you 10 divided by 2 plus 3, or I ask you 10 divided by
2 plus 3 divided by 10. Oh, okay.
10 divided by, wait, it should be put in this way, 2 plus 3 divided by 10. Okay?
Yeah.
No, sorry. I think it has to be put in this way. 10 plus 2, and let me write 96 divided by 10 plus 2, or 10 plus 2 divided by 96.
Okay.
Okay, so what is happening here? 96 divided by 10 plus 2 is how much?
96 divided by 12, 8.
Okay, and 10 plus 2 divided by 96 is how much?
1 by 8.
1 by 8. Now the question is, we have solved it using the bracket first, using the BODMAS. But let us find out whether it works for the distributive property or not. So can I write this 96 by 10 as 96 divided by 10 plus 96 divided by 2? Can I write like this?
No.
I wrote in the division, multiplication, see this. I wrote the same thing in the multiplication, but can I write the same thing in the division as well?
No.
I can't write it because that is not allowed. Okay, 96 by 10 is a different number, 96 by 2 will be a different number. Okay, now can I write it here like this? First I will write 10 by 96 plus 2 by 96. Is it allowed?
No.
Why not?
Isn't it the same?
No, now you see the denominator is same here. So if you add them, they will be added. 10 plus 2 is how much?
Oh yeah, okay. 12 by 96, so 1 by 8.
But here they are not same. You have changed the denominator.
Okay.
The denominator was common to both the 96. Both the denominator are common to 96. You can't split them. Are you getting it? Because different denominators can't be added. But the same denominator can be added. So in the division, if it comes on the right side, we can say the division is right distributive, but it is not left distributive.
Okay.
So it is not about just learning the distributive property, but you have to learn that there is a right distribution and there is a left distribution as well.
Gotcha.
For multiplication, it is happening from both the ends, but for the division, it is happening from the right side, not from the left side. Are you getting it?
Yes.
Good one. So we were discussing this part. So we say that it is not only the left distributive, but it is also the right distributive as well.
Okay.
Because we are multiplying. So J times K plus L can be written as JK plus JL, or it can be written as K plus L times J.
KJ plus LJ.
Okay. So these are two different aspects. This is different, this is different. They both are not equal because PQ is not equal to QP. So JK plus JL is obviously not equal to KJ plus LJ. You will get a different result. But KJ plus LJ can be written as K plus L. First you do K plus L and then you multiply it by J.
Yeah.
So, and matrix multiplication is also associated. Please write this down. I gave the order yesterday for that book, ML Agarwal. Let me see when it will reach. It was supposed to reach by today. So probably, yeah, probably it might come by today night or tomorrow as well.
Okay.
So in day after tomorrow's class, we will be on the same page. You will turn the page, I will turn the page, I will be looking at the question.
Sure.
I didn't find that the Kindle edition. If it was in a Kindle edition, then it will be a better portion. I can show you here.
Hmm. Okay. I think there is the same book but different print. My teacher has it and it also has an online copy.
Do you have an online copy of that?
I never looked for it because I have the textbook. I can look for it. I'll let you know.
Just check it out. If it is there, you can just post me, because it
Yeah.
will be, see, this is the beautification that we do for the students. If it is in neat and clean manner, you will like it to do the questions as well.
Okay. Yeah.
Done?
Yes.
So AC is associative as well. You can multiply BC first and then multiply AB first. You can do anyways. But I think I never saw any questions multiplying three matrices. So solve matrix equations. So you may be given a question like this: x minus something is this. So how to find the x? So you will take this on the other side, and when you linear equation, I told you 80% of the mathematics is linear equation in one variable.
Yes.
And then you can add them and you can find the result. See, 2 plus 3 is how much? 5. 1 plus 0 is 1. 9 plus 1, 9 minus 1 is 8. And 7 minus 7 is 0. It was that easy. Sometimes this may be given on this side. So you have to bring this side. So 8 minus 5 will be 3 minus 3. No, why? Okay, this is not the final result. So x will be equal to, you have to multiply by minus 1. So you will get 3 and negative 30.
Okay.
This will be the final result. So take x on the other side, bring 5 on this side. So 8 minus 5 is 3, minus 4 minus 9 is minus 13. Easy?
Yes.
Okay, now time to do questions now. So what you can do is you can log in with the IXL, and we will be looking at here. I will be just checking out whether you are doing it correctly or not. So right now I have given you the demo account. If you like it, so you and your sister both can do from the same account, but I will give you a separate account that need to be purchased. Okay?
Yeah. Sure.
So that will be what?
So you can look at my progress.
Yeah, I can look at your, because this is a demo account, so it is given to the several students, 2-3 students. So I am not getting who is doing what. So if you want, I can make the account for you as of now. So if you like it, then we can discuss with your mom for the subscription. It will be valid for you up to next year 30th June. And I am sure that next year also you will ask me, sir, I want one more. So this every year it is to be renewed.
Okay.
Yeah, so I have 2 left with me. I can make one for you right now. Just give me a minute. I will make one for you so that you can log into your own account and you can do it.
Sure.
Just give me a minute.
Yeah, definitely.
You are in grade 10. Okay. So you are in a WhatsApp group, right?
Yeah.
I am just putting the user ID and the password. You don't need to say anything. Just look at it and type it. Log in with your IXL account.
Okay.
The first one is the user ID. The second one is the password.
Okay.
Done? Yeah, please log in. So it was in pre-calculus. This is of grade 11 actually for the CBSE, and this is a US curriculum. So in the US also it is being taught in grade 11 pre-calculus. But in ICSE it is being taught earlier because it has got to do with one or more topic, that is determinant. But in your topic determinant is not there, so it's okay.
Okay.
So up to up to Q9 you have to do. So why not to start from Q9? Reverse, yes.
Okay.
If we do the toughest part, then the easiest part can be done easily.
Yeah, sure.
So let me show you. I will show you how to do 3-4 questions, 1 or 2 questions, and then you can do it yourself.
Yeah, sure.
Solve the matrix equation for x. Simplify all the elements. So x plus something is equal to this. So first of all, I have to find what is x. So I will take this on the other side.
Yeah.
So when it will go on the other side, what will happen? It will be subtracted. You can see the -3 will become +3, 8 will become -8, 9 will become -9, 7 will become -7. Are you getting it?
Yes.
So the matrix, first of all, we have to understand whether the matrix addition exists or not. So if the matrix does not exist, you have to click on undefined. And if it do exist, then you have to find what kind of matrix is this. So let us find.
I did this today.
Huh?
I did this today.
Okay, you did this Q9?
Yeah. No, I didn't do Q9. I did something similar to undefined, etc.
Okay. So in this case, you have to first choose what kind of matrix is this. So this is 2 by 2 matrix. So I am going to write 2 by 2. Click on 2 by 2. I've got 4 parts. Now first 8, this will become +3. So 8 plus 3 is how much? 11. So I will fill this with 11. Then 2 minus 8 will be -6. Then 2 minus 9 will be -7. And then 2 minus 7 will be -5. Okay, and then you will submit and you will get your result. So please do Q9, start doing Q9. Let me see how fast you can do. And it is a time taking process as well. The time is also counted, each and everything is counted. Okay, on the right side, if you see, there is a timer going on and there is a marks going on. So if you gain 100 marks, then it means that you have completed the sheet, you have mastered the skill, and you will get a gold medal as well, virtual gold medal. So start doing it in your own sheet.
Okay.
Very good. So well done. Next question.
Yeah.
If we have 3-4 students, all the students do at the same time, I can look at what they are doing.
Okay.
So this is connected with me.
Okay.
Yes. See how many questions you have done correct, wrong. Every data I have.
Okay.
Wonderful. Good going.
Yes.
Good one. So you have got 55 marks. I can ensure that you can do the rest of by yourself in your own time. So why don't you try this Q6?
Q6. So I can just go back without completing it.
Yeah, it's okay. You can complete it later on. It will reflect the progress is saved with you. So Q6.
Oh.
And Q6 you can't do until you do in your notebook. So first you have to do in the notebook and then you have to fill up the answers here.
Okay. Do I do it now?
Yeah, please do it. At least one question, or you can help me in doing my question. If you can help me in doing my question, that will be great. And if you get the right answers, I can ensure that the rest of the questions you can do by yourself. And the chapter is finished as well.
Oh, we're done already.
In fact, the chapter is finished. You turn out your page on the textbook. Just look at the question. Tell me if any question is there which you are not able to understand. And then let's do this question and we can end up the class.
Yeah, sure.
Is there any question which you are not able to understand?
No, everything seems simple. What we did down.
So it is simple actually.
Okay.
See, just a single class made a lot of difference. Okay.
Yeah.
Okay. So let us help me to do this. So tell me, is it allowed first?
Yes.
Okay. So what will be the final answer? What will be the order of the final product?
2 by 2.
2 by 2. Okay. Tell me the first part. What will come?
Just a minute, I'll write it down so that it is simple. Four plus -7. So -3.
Very good.
Second. So 8 plus -14. So -6.
Very good.
-1 plus -6, -7.
Very good.
And -2 plus -12, -14.
-14. So please note it down. I will ask you. So 2 by 2 matrix. What was this?
That was -3.
Okay.
Just give me a minute. I didn't completely write the answer. I just wrote this step.
Okay. Please
And then
write down.
-3, -6, -7, and -14. Yeah.
So -6. Here it is -7.
And yeah, -14.
Okay. Great job. So you can do a lot of great job, good work done. Okay, excellent, fantastic. You will get a lot of adjectives. So please do it by yourself, and we'll meet in the next class. That is on Saturday.
Yeah, same time.
Yes, same time. And one more thing I want to make you understand. See, the theory part is clear. This particular part will be also clear to you. Once you do all these questions, you can practice and assess yourself. I will also assess whether how much you have done it. But the main thing is you should also know how to write in the examinations, because you will get the marking for every. There is a marking scheme for every step. So you do all the examples from your textbook. At least in the examples you will get to know what are the steps that needs to be written. No need to do all the questions, but there is a need to do all the examples at least. Okay, and after the examples you can check randomly any question, you pick it up, the last question in the middle one, one in the middle, one in the last, and first question. You do 3 questions from an exercise, and if all of them are true, you can check from the back side of the answer. If all of them are true, no problem in that. If you are stuck in anything, you can immediately send the picture of that question. I will try to find out, and we will get rid of those particular kind of questions in the next class. All right?
Yeah.
So you have to manage the time, and you have to do it. Or what will happen? We will be learning new topics, and the old topics will be washed off from your mind.
Okay. Yes.
So if you do want to start the trigonometry in the next class, please complete this particular part. You have 1 day time. If you are not able to do it, we can practice one more day. We can practice one more day. There is no harm in that. But learning, switching to a new topic without doing the previous topic will not help you out.
Yes.
Okay? And multiplication table up to 19 you have to remember. I will help you in that. If you are not able to remember by yourself, in 5 minutes I will keep making you learn each multiplication table. At least the table of 13, 17 and 19. These 3 are prime numbers.
Okay, 13, 17 and 19.
Yeah, 14 you can manage by dividing it by 2 and 7. 15 you can manage by dividing it by 3 and 5. That's not a problem. 18 you can manage by divide. If you know the table of 9, 18 can be managed. But the table of 13, 17 and 19 can't be managed.
Yeah, because prime numbers.
Prime numbers, they don't have any other factors.
Yeah,
Okay?
sure.
Chalo. Bye. You like the class?
Yeah, I loved it. That's why I wanted to join.
Okay, fine. Bye.